All right, so I think we can go ahead and start. It looks like a number of participants stable enough. One person just joined, and those who are running late, there's one more. Okay, so there's still people joining. But anyways, so let's not waste our time. We have 1 hour here. Welcome to Momentum Learning AP Physics 1 exam preparation open house. My name is Dr. Ibrahim Albayrak. I'm an experimental nuclear physicist. I have my PhD in experimental nuclear physics. I'm still doing my research, nuclear physics research at Jefferson Lab in Virginia. I have been teaching so many physics courses over the years. Right now, currently, I'm teaching at the Governor Schools for Science and Technology. I'm teaching there modern physics, programming with C++, and some engineering courses. So if you have any questions about myself, you can put it in the chat box or just unmute and tell me. So I'm going to be giving this course this semester. I am the instructor, so it's going to be on Sundays between 5 and 7 p.m. Central Time. So in my time, Eastern Time, it's going to be 6 to 9. And we are going to start on February 4, and it's going to last until April 28. So it's going to be 12 weeks, I think. And every week we're going to spend 2 hours. No class on March 10. And one thing important about this course is this is not AP Physics 1 course. It is AP Physics 1 exam preparation. So in this course, I am assuming that the students have already taken AP Physics 1 in school or anywhere else. We are also providing that course, but I'm not giving AP Physics 1 course. This is mostly like problem solving, preparing students for the exam. Okay, so we are assuming everyone has taken AP Physics 1 or an equivalent course in school or somewhere else. If you have no prior physics knowledge, or if you haven't taken AP Physics 1, then please look into taking AP Physics 1 class. Okay, so not AP exam prep. So we provide both of them, and I think we are going to be opening AP Physics 1, 2 in parallel. I think it was going to start February 17th, something like that. I don't know, you can ask. All right. So class description. So AP, this is for preparation for AP Physics test. It's an algebra-based test that will test your understanding of the scientific concepts covered in the AP Physics 1 course. AP Physics 1 is mostly classical mechanics, Newtonian physics, what we call it, right? So it's going to be related to kinematics, dynamics, energy work, momentum, those kind of topics. They're going to be tested in this test. In 2021, the AP Physics 1 exam had the lowest passing rate. So it's a challenging exam. And I think one of the most challenging exams out there. Only 42% of students who took the AP Physics 1 exam passed it. So less than half. And only 7% got a 5, the high score. So getting a higher score, I mean, is challenging. So this class will prepare students for the upcoming AP Physics 1 test in May. I think it's on May 17, something like that. I have the date in my following slides. So it's going to be in May. Exam, you're going to be able to use, and also in the class, of course, you're going to need a calculator for function, at least scientific or graphing calculator throughout the exam. It's allowed. They're going to give you formulas and conversion factors, etc., in the on the question book. So in this course, there's going to be, in addition to the content we cover, there's going to be homework questions weekly. So they shouldn't take more than 45 to 90 minutes to complete. So that's on average what this course is all about. So as in the previous slide, as I said, this is a challenging exam, and many students don't even get the higher scores. So it's very challenging to get 4 or 5 on the test, which are the higher scores. And you see the percentages and comparison to other AP Physics tests. So AP Physics 1 is one of the most challenging tests out there. Okay, so the exam has two parts. The first part is multiple choice questions. So there are 50 multiple choice questions in the first part, and you have 90 minutes for that. So first part, 90 minutes and multiple choice questions. This is kind of relatively easy part because you have multiple choices and questions. I'm going to show you some examples of questions. Not so challenging. And then the second part, which is also 90 minutes, is called free response questions. So this is kind of the challenging part of the test or exam. You're going to have 5 different questions here, and you're going to spend 90 minutes on 5 questions. So remember, 90 minutes on 50 questions in the first part, and 90 minutes and another 90 minutes on only 5 questions in the second part. So you're going to have 5 questions in the free response. So that means they are not multiple choice questions. Here there are 3 types of questions in the second part. One is experimental design. So they're trying to understand your experimental skills and your understanding of data, interpretation of data, etc., collected during an experiment. There is also qualitative, quantitative translation. I have some more details in the next slide. So, and then 3 short answer questions. So these are going to require you to write a little paragraph to explain your answer. So that is what short answer questions are. And so their weights, the weights of these 5 questions are not same. So experimental design and qualitative, quantitative translation questions, the first 2 types of questions, they weight more. So you're going to get 12 points out of each question, each of the first 2 types of questions. And then the other 3 questions, short answer questions, their weights are less. So you're going to get 7 points, almost half of the first 2 types of the questions. And then for that reason, so it's going to be, obviously, short answer questions are going to be a little easier than the other 2. And for that reason, during this part of the test, you're going to be spending most of your time on the first 2 types of question, right? And that's what they also recommend. So spending like something like 25 minutes for one question, 25 minutes for the other question, and then 13 minutes for the rest of the questions. Okay. This is where you're going to spend most of the time, and I think this is where we are also going to spend most of our time during this class. The exact date of the exam is Friday, May 17th, for this year. Okay, so these are the topics. I mean, probably you guys are already familiar with these because, as I said, so we're assuming that you guys have taken AP Physics 1 course already. So you must have knowledge of all these things so far. So we are going to continue and expand our understanding of these topics. So unit 1 is kinematics. So there's no force concept in here. It's just kinematics, velocity, acceleration, and motion in general. And then the second unit, we discussed dynamics. Dynamics is kinematics together with the source of the motion, which is the force. So we're involving forces here. And then the law, the physical law that gives the relationship between motion and forces are called Newton's laws. So we're going to discuss basically Newton's 3 laws: first law, second law, and third law. And as part of this, we're going to also discuss or review gravitational forces. And this third part, we discuss circular motion. So one thing good about circular motion is it's analogous to linear motion. So whatever we have learned in kinematics and dynamics, same rules apply in circular motion. We're going to be using the same equations, and everything is going to be same as long as you replace relevant quantities you found in linear motion. So circular motion, if you have a good understanding of kinematics or dynamics, then circular motion is going to be easy. And then other important concepts in physics 1, work and energy concepts. They are very closely related. So we're going to review work energy theorem, kinetic energy concepts of like potential energy, kinetic energy, and total mechanical energy, in addition to the concept of work. And then finally, one of the, again, most important concepts in physics and in physics 1, momentum. So we're going to discuss momentum here, and we're going to discuss linear and angular momentum together. So linear momentum is momentum of objects due to their linear motion, and angular momentum is the momentum of an object due to their rotational motion. And then simple harmonic motion it's part of circular motion, so we can combine these two and discuss them together. And then torque rotational motion, again, it's part of the circular motion, rotational motion. So these are basically the topics that is covered in physics 1. And again, we're not going to go into details of these. We're not going to derive equations. I'm not going to derive any equations here because I'm assuming that everybody has taken this physics 1 course. So I'm assuming everyone has a good understanding of these topics. So what I'm going to do is I'm just going to review. I'm going to remind you the essential points, and then we're going to go ahead and solve basically problems. All right. Okay, so far, I mean, I'm not asking if any questions. There's going to be a question and answers session at the end. But if you want me to stop and if you want to ask questions, you can put your questions in the chat box or just unmute if there's something unclear. But again, there's going to be a questions and answer session, Q&A session at the end. So for this course and for every other courses, I think we provide, we have Canvas pages. So we're doing this on Canvas. I don't know if everybody's familiar with Canvas. Many school systems today use Canvas, including my own institution here. We're using Canvas too. So it's getting popular. It's becoming popular among school systems. So on our Canvas page, you're going to find everything you're going to need for this course. So on the main page, there's the general information. So starting date of the course, name of the course, instructor. If there's any holidays, you're going to find it in here too. For example, it says no class on March 10, right? So in general information is going to be in the main page here. And then all the classes we are going to be holding, they're going to be on Zoom. And then the main page is going to have a link for the Zoom session too. So if you click the join your class live, then you're just going to join your class Zoom session there. And we're going to use Canvas also to share class material. I'm going to be posting class material, the homeworks and everything else is going to be here too, right? And the solutions of the homeworks are going to be here too. So here on the bottom side of the page, you have weeks. So it's 12-week program. So if you click one of the weeks, you can go ahead and reach the material for that week. You can also access that clicking on the left-hand side menu. There's the modules button there, so it takes you to the same place. You can see your assignments. So left-hand side, there are many on the menu. There are many things you can do. You can see your assignments in one page. If there's any discussion going on, you can also join discussions there. You can check your grades there, right? So files, if there's any files uploaded, course material, you can also reach them there, right? Most of the time, you're not going to be using those, but in general, everything you would need is going to be on the main page here in the middle. So as I said, if you click one of the weeks, for example, you're going to go to that week. For example, let's say you clicked week 1, or you clicked modules on the left-hand side. It's going to take you to the modules. And then you're going to see modules for every week. All right. you're going to see the modules for every week. So you're going to find the handout shared for that week. So you can go ahead and study it before or after the course, after taking, after discussing the material of that week. You're going to find the homework there too. And then you're going to also find the recording of the class for that week here. Okay, did I forget anything? So weekly, so you're gonna find weekly homework. So it's not gonna be populated. So you're gonna find all the weeks here. So from 1 to 12, but you're not gonna find all the handouts, homeworks, and recordings there, of course, right? So we're gonna populate them when it comes to that point. So in week 1, when you take the course, when you start it in week 1, you're gonna find only handout, and then after the course, homework is going to be posted and recording is going to be posted. And then week 2 is going to have the same things when it comes to that point. All right. Yes, so I have one question. It says, can I look at past week content? So all the weeks are going to be here, right? So you of course, you can look at the past week contents and everything, recordings. They're going to be here. Not only past week. I think when you're finished with the course, you're going to be able to look at everything for 3 more months after we finish the course. So you're going to have access to all of these things for an extra 3 months. Okay. Canvas invite links are typically sent out to students, not parents. So watch your emails 4 or 5 days prior to the start date. So watch your emails or messages. You're going to get a Canvas invite link. This is the Canvas course, so you're going to get an invite link, and then that's how you're going to register for the class. Okay, so I think that's all about the course. So we are preparing students for AP Physics 1 exam. And then we're assuming that every student has already taken AP Physics 1 or an equivalent course in the homeschool or anywhere else. And then we are going to be doing this on Canvas, and then live sessions are going to be on Zoom. All right. So that's all I have as far as the exam concerned and the Canvas course is concerned. So now I'm going to go ahead and show you what we are going to be doing during these classes. Okay, so I'm just going to show you how I review the courses, because since I'm not going to be going into details and I'm assuming that everyone has taken AP Physics 1. So I'm just going to make a quick review of the concepts and then start working on problems. Okay, so this is what it looks like. Let's say, let me open up my, okay. So let's say this is the first week. So I mean, probably these are the students who are going to take the course. So I'm just going to start my course shortly here and then do the first part of it, right? So physics is all about understanding the universe, right? So we start from there. Understanding the universe, or understanding the workings of the universe, or understanding the interaction of objects, particles, etc. So what do we do to understand the universe, right? Physics is all about understanding the universe. What do we do to understand the universe? We make measurements, right? We measure the universe. We make measurements, right? So there are 2 important points about these measurements. First, we cannot measure things with infinite precision. So there's going to be always uncertainties, right? There's going to be always uncertainties. Let's say you measure the temperature, right? So temperature, you found it to be 60 degrees. But this is not an accurate description or accurate quoting the measurements, right? So because you cannot measure anything with infinite precision. So whenever you measure something, you need to provide an uncertainty. Let's say here, our measurement device, the uncertainty in our measurement is at 1 degree. So you should say it's 60 degrees plus or minus 1 degree. Okay, so there's going to be always uncertainties in your measurements, right? That's one of the concepts you're going to remember, you're going to need to remember, right? So sometimes uncertainties are given in terms of 1 plus or minus, or sometimes they're given in percent. So probably you guys already remember those, right? The other thing about our measurements, so one thing is an uncertainty in measurements, all right? There's always an uncertainty. And the other thing is, so we are going to be measuring various things, right? Various quantities. Various quantities. So how am I going to distinguish these, right? So I measure temperature, right? I measure temperature, I found it 60. I measure velocity, I found it 60. I measure, you name it, position, I found it 60. So all of them, I mean, have their values are 60. So how am I going to distinguish these things, right? So temperature is different than velocity. Velocity is different than a position, right? So for this purpose, for every type of measurement, we invent also units. So we use units. For temperature, we have several different units. So it can be a Fahrenheit or Celsius degrees, right? And then for velocity, to indicate that the measured quantity or the quantity in question is velocity, we use velocity units, meters per second, we say, right? Or miles per hour, whichever the one you use, but you need to use a unit for velocity. And then position. Position is a distance. So we use meters or inches or you name it, right? Yards, etc. But you need to have units. So, and your units are needs to be consistent, right? So for example, for velocity, if you're using meters per second, for distances, you cannot use inches, right? You cannot do that because you're using meters for velocity, meters per second. So your units needs to be consistent, right? For that reason, if you're using meters per second for velocity, your unit for the position, it needs to be meters, right? And then we have the consistent system of units. We call it standard units, SI units, right? And in physics, most of the time we use these things, right? So in SI units, distances are given with meters, and then velocity is meters per second. That means time is given in seconds, right? You can have a different unit for time too. So distances are given in meters, timing is given in seconds, etc. So these are called SI units. Energy is given in joules, etc. Okay, so these are the units. So let's go back one step. So we understand the universe, we make measurements, and our measurements, there are different types of measurements. We measure different types of quantities, temperature, velocity, position, energy, momentum, etc. Right? And all of them have units. So this is one way of categorizing measurements. But measurements, I mean, the quantities that we measure, they also have another important feature, right? So there are two types of quantities. Two in general, of course, two types of physical quantities. Right? One is called scalar quantities. The other one is called vector quantities. Right? Scalar ones are like the ones temperature, right? Temperature 60 degrees. So if you know the temperature at some certain point, you know the temperature at that point. And that's all you need to know about it, right? That's all you need to know about it. If in this room, temperature is 60 degrees, that's it. That's all I want to know. So these kind of quantities are called scalar quantities. The vector quantities, let's give an example. Let's say velocity is, right? Velocity of a car, for example, right? 25 miles per hour, right? This is the velocity of a car. Is this what is this the only thing that I need to know about the velocity of the car? Right? Unlike scalar quantities, unlike temperature, this is not the only thing that I need to know, right? Because velocity describes a motion. So in this case, direction of the motion is also important. So in addition to the magnitude of the measured quantity, velocity in this case, I also need to know in which direction it's moving, right? So you have a car, right? It might be moving east with 25 miles per hour, right? Or this can represent a car, right? Moving at a velocity 25 miles per hour towards west. So which one, right? So just putting the velocity 25 miles per hour is not enough in this kind for this kind of physical quantity. You also need to tell me in which direction it's moving, right? So these kind of quantities, they're called vectors. So vectors are the quantities, physical quantities that has magnitude, just like scalar quantities, but they also have direction. So to indicate vectors, we use in physics arrows, right? So it can be any vector, right? Velocity vector or momentum vector or acceleration vector, whatever the vectors you have. So in general, it can be an A vector. And to indicate that it's a vector, we put a vector sign, an arrow sign on top of the symbol. So this is a vector. So its magnitude tells me the magnitude of it, its size, right? Its length tells me the magnitude of it. So it's 10, let's say, units of distance, its length. So if it's a velocity, that means it's going to be 10 meters per second. If this vector represents an acceleration, then it's 10 meters per second square acceleration, right, etc. So its length represents the magnitude of the vector, and its direction is given by the direction of the vector. So that means you can have, if you have another vector, then that vector can point any other direction. So let's say this is the B vector, right? And then obviously it's a smaller vector, so its magnitude is smaller. So if A and B is representing velocities, for example, the vector A represents a faster velocity, and vector B represents a smaller velocity, a slower object, right? And then their directions are given by the direction of the vector. So these are the vector quantities, right? So what do we do with these, right? So we have vector quantities, we have scalar quantities. So we know what to do with scalar quantities, right? So for example, let me give you a simple example again, scalar. Scalar are the easiest stuff because we are dealing with scalar quantities in our daily life. Even if you're not a physicist, you do everything with scalar. For example, money is a scalar quantity. You have $10,000 today, and then you got the paycheck tomorrow, right? Depending on the paycheck, let's say you got $5,000 more, then you have 15, right? So, right? So your total income, you had $10,000, right? In scientific notation, it's 10 to 3, sorry, 10 to 4, right? 10,000. And then plus you got $5,000, right? This week. And then in total, you get $15,000 in your pocket. So this is what a scalar quantity is, right? So temperature, it was 60 degrees. You turn the heat on, and then the heater added, increased the temperature 5 degrees. So 65. So this is, what I'm trying to say is regular algebra works with scalar quantities, right? Because they don't have any directions. So we just use regular algebra to deal with scalar quantities. But for vector quantities, scalar algebra doesn't work, right? Why? Let me give you a simple example, right? Let's say, let's use forces, okay? So let's have a box on a flat surface. So I apply a force of, let's say, 10 newtons in the east direction. Let's call this force F1, right? So I apply another force in the west direction, F2, and let's say it's 5 newtons. So I'm asking you to tell me what is the total force acting on this object. What is the total force acting on this object? So total force, why did I say it's zero? It's, I think, habit. Right, so what is the total force? So total force is normally, right, F1 plus F2, right? That's what total force is. But remember, these are vector quantities, so you cannot just do this. 10 plus 5, then the total force is 15, which is wrong, right? These are vector quantities, so you need to consider their directions. So to do this, right, in x direction, let's say this is in x direction, and then you can have y direction and z directions too, right? We are living in three-dimensional space. But most of the time, questions are going to be asked in only one direction, so it's going to be easy. So, right, in one direction, in x direction. So what is the total force then? So one of the forces is 10, right? This guy is 10. And then its direction is the positive x direction. So I take that as a positive direction, right? So this positive symbol represents the direction of the force. And then the other force, right, points towards the negative x direction, which is the opposite direction. So what I do here is, right, direction represents negative is represented by direction. So the total force acting on the object is actually 5 in the positive x direction. So this situation is equivalent to this situation, right? You have a box and you are applying just total force 5 newtons force, right? So if someone is pulling the box towards east with 10 newton force and another person pulls it in the opposite direction at 5 newtons force, so total effect is you're pulling the box in the east direction with a 5 newtons force, right? So this is how we deal with vectors. So this is called vector operation. As you can see, it's not a regular algebra. It's a vector algebra. So we need to know what vector algebra is, okay? And then probably you guys have learned it in previous years when you take the AP Physics course, right? So you do vector algebra. So simply, vector algebra is this. If you have a vector A and if you have a vector B, I mean, let's not put them next to each other, right? So you have a vector B. I'm just doing this most general form, right? So, and if you're talking about vector A plus vector B, then it is this. You can, let's say the magnitudes of them is 10 and 10. So their magnitudes are same, but directions are not same. So you cannot just say 20, right? This is wrong. So you cannot just say 20. So instead, what do we do here? We take vector A, which is this, right? And we take vector B, which is that. And then, right, the sum vector is going to be, when we join the tail of vector A to the tip of vector B. So this is going to be what A plus B is. So its direction is going to be that, and then its magnitude is going to be this. Of course, this is a geometric method, so you need to apply geometric rules to find its magnitude and its direction, right? The direction is going to be given by the angle or etc. But this is one way of doing working with vectors. The other way, and I think it's the easier way, is using vector components. For example, let's say you have vector A, you have vector B, and then you're going to do a vector algebra, right? So let's again say vector A plus B, right? So you're looking for this. So separate find the components of your vectors in every direction, right? And then do this for every component. For example, AX, X component, and then BX, X component of B. Find that, and then find Y components, BY, find that. And if you have in 3 dimensions, then you can find Z component too, right? So this is going to give you the actual vector. So finding the components, right? So let's say the sum vector is C, right? So A plus B is equal to C. Then this is going to give you C, X component of C, Y component of C, and then z component of the c. So from these components, you can find the c vector, right? So how do we find components? So in 2 dimensions, it's simply by this, right? So you have x coordinate, y coordinate, and then you have a vector in here. It doesn't matter its direction, right? So this is what it is. So x component is its projection, right, on the x direction. So this is the x component of the vector. If this is vector A, then this is ax, and then projection in the direction of y, this is ay. And do the same thing for B, and then calculate these. So as soon as you find the components, then the rest becomes regular algebra, right? Regular algebra. Because you can forget about vectors because you were working with their components, right? So this is the good side of this method. So if you find the components, then vector algebra reduces to regular algebra. So you can just sum their values, right? And then when you find the components of the final vector, cx, cy, and cz, right? Then from those you can find, I mean, let's again do the 2-dimensional case. So let's say this is x, this is y, and then you found these components. Let's say this is the x component, cx, and then let's say this is the y component, cy, you found from these, right? So cx and then cy. I'm assuming there is no cz, so 2-dimensional case. So your c vector, the final vector, is going to be, right, the sum of these. So this is the c vector, right? So cx and cy is its components. So this is the vector you're looking for, right? The final vector, which is a plus b. So this is how we do vector algebra. Okay, so there are a couple of other points. I'm just going to skip them because I have other questions, right? So this is basically what I do at the beginning of each class, and then continue solving problems, right? So some sample question, I'm going to show you guys some sample questions. For example, this one, right? This is a sample AP exam test question. It's an easy question. So most of the questions, I mean, maybe not most of them, but plenty of them are going to be conceptual like this. So you have an object is moving. Let's read the question. An object is moving to the right with speed vi. So you have an object, it's moving to the right. And then you apply a force. When a force of magnitude F is exerted on it. In which of the following situations is the object's directional motion changing and kinetic energy decreasing at the instant shown? So we expect both of the effects. Directional motion should change, and also speed of the object should decrease, not just change, it should decrease. So if you look at the situation A, you have an object, it's moving in this direction, and you are applying a force perpendicular to its motion. And you guys already know what kind of motion is this. So if you apply a force perpendicular to the directional motion, objects perform circular motion, right? So that force is going to be centripetal force, right? Object is going to move in circles if you have a force perpendicular to the motion. So in this case, directional motion changes. So it satisfies the first part, but the magnitude speed doesn't change, because the force you apply is perpendicular to it. It's not going to change the speed. Speed is going to be same, but direction of the motion is going to change. So this is not the right answer. B, you're applying a force opposite to the directional motion. So it's going to slow the object down, obviously, but it's not going to change the directional motion. So you're going to have an object moving in this direction, and it's going to slow down, and it's going to stop. If you keep applying the force, it's going to go back, right? But directional motion is not going to change. So this is not the right answer. And now let's look at C. So directional motion is in this direction, right? In a positive x direction, and the force is in this direction. So because of this, right, force, this force, remember the vectors we have just discussed, right? So this force is going to have a component. This force, right? Let's write it. Force, and then x and y, right? X, y, and this is the force. And this force is going to have an x component, and it's going to have a y component, right? Fx, Fy. So this force, the x component of this force, right, is applied in the same direction as the velocity, right? So you're applying a force in the same direction as the velocity. So that means this is going to increase the velocity. You are pushing an object in the direction of motion, right? So it's going to increase the velocity, and then y component of the force is going to change the direction of motion. So it's going to make this follow a circle-like trajectory, right? But although it's going to change direction of motion, this force is going to increase the speed, not decrease. So it doesn't apply, right? Because we want the one that changes the direction of motion and also decrease the velocity. So let's look at the last one. That's got to be the one we're looking for, because that's the only option left, right? So in that case, maybe I should just erase everything. Okay, whatever. So in the last case, you have the object moving in this direction, and then you apply a force in that direction. And again, remember, right, the components of the force: y direction, x direction. This is negative x direction. This is positive x direction. Your object is moving in this direction, velocity, right? And the force is in this direction. So your force is going to have two components again: y component and then x component. So as you can see, x component of the force you apply here now working against, right? This is the x component of the force. It's working against the velocity. So that means this force is going to decrease the velocity, and then y component of the force, which is in the perpendicular direction to the direction of motion, is going to make object change its direction of motion. So this object is going to make something like this, right? So it's initially moving in this direction, and because of this force, it's going to move something like this, but it's going to slow down, right? So its directional motion is going to change and slow down. So the right answer is D. Okay, so this is a simple example of the questions we see in AP exam test. Another question is this. I'm not going to go over this because we don't have that much time. And another question is like dynamic sample question. I'm not going to go over all of them, of course, right? So as you can see, I mean, I'm not talking to parents, obviously, the kids who has taken AP Physics 1, they're going to realize that the questions are not that hard. They're easy questions, right? But there's 50 of them, so that makes the test challenging. And then the second part of the test is pretty challenging. So here it says you have 50 Newton box, right? So you have a box on a surface, and it says its weight is 50 Newton. So its weight is 50 Newtons. It's on a horizontal surface. You have static friction coefficient of the surface. It's 0.5, and then kinetic friction coefficient, it's 0.3. So it says if you apply 20 Newtons force to the box, right, in any direction, in this direction, horizontal direction, sorry, to the right or to the left, it doesn't matter. In a horizontal 20 Newton force is exerted in the box. The magnitude of the acceleration, what is it? So what is the acceleration of the box? So acceleration, we use Newton's second law, right? F equals ma. So this is the acceleration. Acceleration is that, therefore, F over m. But here, F is the total force, not this force we apply, because there's a friction force. So we need to find the total force. To be able to find the total force, right? Total force is F minus the friction force, right? So 20 minus whatever the friction force is. So what is the friction force? Friction force is given by friction force coefficient. So let's check the static friction coefficient times the normal force. The normal force is equal to the weight of the object So basically the friction force is 0.5 times 50, it's 25. So you have a friction force and its value is 25 newtons, and it's always opposite to the external force. So you have a friction force and its magnitude is 25 newtons. This is the maximum value of force. So that means to be able to move this object in its place, from its place, you need to apply at least 25 Newton force. Otherwise, the object is not going to move because of the friction force. So that means applying 20 Newton's force is not enough to move the object. So acceleration is just going to be 0 because the object is not going to move, right? So the right answer is going to be A. Okay, another example. This is circular motion or orbital motion. So a spacecraft is placed. So you have a planet here. I'm not reading the question. So you have a planet, and then you have a spacecraft in orbit, right? You have a spacecraft, let's say ISS, International Space Station, around Earth, right? So the planet mass is 6.4 10 to 23 kilograms, and then orbital height, so this distance here is 4.5 times 10 to 7 meters. So what additional information is needed? As you can see, it's not asking us to calculate anything. It's telling us that the missing information here. So what additional information is needed to calculate the speed of the spacecraft? So what is the speed of the spacecraft? Can we find the speed of the spacecraft given this information? So here in this kind of problems, right? So the speed of the spacecraft is related to the orbital motion. So the only thing we need to know in this kind of situation is there's a gravitational attraction force between these two objects, Earth and spacecraft. So the gravitational force is given by this formula, Gm large M over R squared. R is the distance from the center of the planet to the position of the spacecraft. M is the mass of the spacecraft. And then this is the planet mass. So that force, right, to be able to keep a spacecraft in orbit, that force needs to be equal to the centripetal force, mv squared over r, right? This is the centripetal force. And this m is, again, the spacecraft mass, right? So as you can see, you can cancel these. So you don't need to know the mass of the spacecraft. So that means all the spacecrafts are going to have the same speed, regardless of their mass in the same orbit. So this is the velocity. So you can solve this for velocity. I'm not going to do that. But as you can see, I know G, it's going to be given. It's the gravitational constant. The mass of the planet is already given. So only thing I need to know is the radius of the planet, right? Radius of the, I mean, the distance from the center. But we are given the height from the surface of the planet. So we need to know the distance from the center. So radius of the planet also needs to be given here in this problem, so that we know the distance between the center of the planet and the spacecraft, right? So that means planet's radius we need to know. Okay. And then this question. So let's skip these because we don't have time. This is an example of a free response question. So you're basically going to be spending between 10 minutes to 25 minutes for these kind of questions. So in these kind of questions, there's no multiple choice. So you're going to be writing your answer, right? So well, how much time do we have? I think we have 5 more minutes. So let me see what else do I have? Oh, that's okay. That's gonna be it. So in the meantime, so I'm gonna just quickly explain this, but assume this is also the QA session. So if you have any questions, just put your question in the chat box, and I'm gonna also answer those. Okay. So I'm just gonna quickly go over this question and then answer your questions, and that's gonna be the end of the end of the open house. Yeah, you have the information. These are going to be shared with you, I believe. Okay, so if you have any questions, put in the chat box while I'm reviewing this question. So in this question, it says you have two cars and they have magnets and they are on an inclined plane, right? So something like this. Something like this. So they are on an inclined plane. I'm not reading the question. So it says you have a small car, you have a large car, they have magnets attached to them. So, and then there's a repulsion between them, right? So this graph gives the momentum of each car. So the square symbols is the momentum of the big car, 5 kilograms. And then circles are for the small car. And in the meantime, I have a question now. So Luke says, do I get formulas for the test? Yes, all the formulas are going to be given during the test. You're going to be also provided, I think, the paper, whatever you need, okay? The conversion factors and everything. You're going to be able to use calculators in the test. All right. So in this question, it says, based on the graph of the momentums of both cars, right? Based on the graph where the measurements at this, so where the measurements started at the instant the cards were released. So this tests your understanding of measurements, right? Or experimental setups. So the horizontal axis is time, and then vertical axis is the momentum. It says where the measurement started at the instant the cards were released. Normally you release the cards from rest. So that means initial velocities, right, is 0 because you release them from rest. So as you can see, the time 0, you have some momentum. That means you haven't started taking this data at the beginning, right? So when you release, so you started taking this data after your release. So the answer is no, because the momentums at t equals 0, p is not 0. Okay. I have another question in the chat box. It says, does this also cover AP Physics C? Is this only AP Physics 1? This is only AP Physics 1, not AP Physics C. Okay. All right. So that's the first part. I mean, you can have a short explanation here. Since we don't have time, I'm not doing that. So you're going to write your answer, and then you're going to justify your answer by a short explanation. And then calculate the magnitude of the external force on the system. External force, so you need to know what external force is. External force is not the force of, I mean, it's got to be the force of gravity, actually, right, in this case. So the force due to the magnets is not external force because it's part of the system. So it's only the force of gravity. So how do I find that? So external force, you just need to remember this, right? Delta P over delta T. So force is equal to change in the momentum over time. So find the total momentum here, right? Total momentum of objects, and then divide it by the total time, right? You're going to find the external force from there, right? So change in the total momentum and change in the total time, right? So change in the total momentum is this. So you have momentum here, you have momentum here. So find P1 plus P2 initial, and then, right, P1 plus P2 final. So this is going to be your initial momentum. This is going to be your final momentum, right? Final momentums are these. So P1 final and P2 final. And these are initials, P1 initial, P2 initial. And then delta P is just P final minus P initial, right? And then use this to find the external force. Okay. I have another question in the chat box. Oh, I have multiple questions. No, one question. Okay. Would friction and air resistance and drag also act as an external forces? They would. So, but problem is going to tell you most of the times at the beginning of the test, they're going to tell you that you are going to need to ignore air resistance or drag forces or external, friction forces. So if there's friction, of course, you need to take that into account. But in this problem, it doesn't talk about any friction forces. It doesn't talk about air drag or something. So you just ignore them. Okay, so it's going to be told at the beginning of the test which forces, which type of forces you're going to ignore. Okay, and then there's the third part. So it says if you change the masses. So what if the first, what if the small mass is 2 kilograms and 4 kilograms instead of 1 and 5? Would your answer change for B? So the answer should be no, because total mass in both cases is same, right? Total mass is 6 kilograms here, total mass is 6 kilograms here. So as far as external forces is concerned, right, and as long as your total mass is same, nothing is going to be different. So everything is going to be same. So nothing's going to change. Okay, so I think that's all I have tonight. So let me know if you have any questions about the course, about the exam, right? This is the contact information of the Momentum Learning. You can email them, you can call them. And so if you want to communicate with me after class started, this is the main point of communication with the instructor. So you can send me messages here. Canvas allows you to send messages. Okay, I think there should be something on the left-hand side, or if you go to the Canvas page, you're going to find there's also a messaging section, and then so you can send messages and receive messages. All right, I have another question. How much work do we need to show on the exam? Because I know there can be points taken off for that. So that's an arbitrary question. I mean, you need to show enough work, right? So you just need to be able to. So I believe you're talking about the free response questions, because for the others, you don't need to show any work because they are multiple choice. So for the free response questions, you need to be able to show everything they need. For example, here, I didn't have the enough work, but so the answer for the first one was no, right? And then in the justification, the short but enough explanation. So you can say at time t equals 0, momentum 1 is not 0 and momentum 2 is not 0. So right, cars have velocities, right? That means since we release them from rest, their initial velocity is 0. Since they have velocities, we didn't take we didn't take the measurements, or the measurements weren't taken at the start, at the instant the car's released. Okay, because it was, if that was the case, they should have started from 0, not from somewhere else. So that kind of thing you need to have, but we're going to work on these during the class. So this is one of the main focus, actually, we need to work on, because it depends on the question. It depends on a lot of things. Okay. But yes, so if you miss some information, some points might be taken. Okay. Any other questions? I think we are already past 1 hour here. So if there's no more questions, then I'm going to end it here, right? And hope to see you guys in the class. All right. Have a good night, everyone.